Any questions on that? Yeah.
So I just have a quick question. So with like the graphing ones where like it shows like the line and stuff like that, are we gonna have to like find the line? And I don't know how we're gonna be able to do that like for the test where we have to write it into a notebook.
No, you're not gonna have to sketch any graphs with me.
Okay, that's kind of what I was saying because I got a little confused.
Okay.
I was like, I don't know how I'm gonna write that in a notebook.
No, it's just that I just figured that with Desmos, like if I did ask, you could always just, have Desmos sketch the graph and then copy, the screen and paste it into your test. I just figured that would be like better instead of having you sketch it by hand. So.
Oh, okay. Thank you.
I hope that made sense. So basically, you're not going to have to graph by hand in my test. So, all right. Any other questions? Good question. All right. So these are just the graphs that the areas I was referring to. So for the first part A, the area to the left of 15, right? That's what the 0.2119 is. And for 22 over here, okay, that's what the 0.9773 is. Okay? That's really what I was trying to say. So again, you get the z-score for less than, and you go to the table. That's really what it boils down to. Just make sure you convert it to a percent like I did. Okay? All right. Here's another one. Suppose now, okay? Suppose now that the test scores, the data set, we have a different test, I guess, out of 10, the test scores are out of 10. Let's say now the scores, they're normally distributed with a mean of 6 and a standard deviation of 0.3. So now we want to know what percentage of students scored less than 6.5 and what percentage of students scored less than 5.5. In other words, what percentage of test scores are less than 6.5 and less than 5.5. That's what we're looking for. So it's the same thing, right? We're going to use z-scores, okay? So it's the same thing. We're going to use z-scores. So first, we're going to use 6.5, okay? So for the z-score, the mean we have is 6. Here, let me underline that. That might be better. Here's the mean, 6. And we have the standard deviation, okay? Right? The data value minus the mean divided by the standard deviation, okay? And that's equal to 0.5 over 0.3. I mean, I wrote it, it's the same thing as 5 over 3, but you could just use a calculator. You get about this, 1.667. Now this, if you actually look in the table, 1.667 is not there, okay? It's not there. So what do? You're going to have to round this to 1 decimal place, to 1.7. That's what you would have to do. It's not bad to do that, of course. It's not that hard to do. But if you looked in the table, I'm not going to switch back to the table because that's going to, it's going to, I guess, I can't share two things at once unless you stick with the notes. But it turns out you get the area is 0.9554, the area we're looking for. Okay. And so that means about 95.54% of the data values are less than 6.5. So about 95.54% of the test scores are less than 6.5. Most of them. Okay, now that's for 6.5. What about 5.5? Well, in this case, it's really the same idea. You subtract the mean, divide by the standard deviation. Here, it turns out you get negative 1.667. Here we got 1.667, but here we get negative that. And as before, this is not in the table. You know what? Let me show you. Feel better. I should show. You can see that negative 1.667 and 1.667, they're not in here. There's no z-score like that. I mean, I'm sure they're in some table somewhere, just not in this book. But that's okay. For us, we could just round it to one decimal place. So for negative 1.7, we would get the area as, in the first column from the left for z-scores, the second row from the bottom, you get 0.0446. So that's the area we get there. That's the area we get there. Okay. Okay, so as a percent, we get 4.46. So that means the percentage of data values, or in this case, test scores, is less than 5.5. It's about 4.46%. Good. All right, good. Okay, any questions on this? Yeah.
So are you gonna give us like all the numbers to get the z-square, or are we gonna have to find the numbers to find the z-square?
Z-score, you mean?
Oh, z-score, I'm sorry.
That's okay. That's okay. I might have said z-square by mistake. So, I mean, I'll definitely give you enough to find it if I want you to find it, though.
Okay, yeah, because I just like some things like some equations like you have to find the number to find what you have to put in the equation. I was just making sure of that
It's
because like
okay.
that's what you were explaining to us, so I kind of just wanted to.
That's okay. All right. Yeah. I mean, something like this, I mean, you definitely have enough. So for the z-score, you need the data value, the mean, and the standard deviation. If you want to find the data value, then you would need the mean, standard deviation, and the z-score. So you'll have enough in the question. Okay, good question. Any other questions? Yeah.
On a test, would we have to find the area, like the percentage, meaning like the table that you were showing before?
Well, that table is in the textbook, which you can get from Lumen.
Okay.
So you have it. You actually have it already then.
Okay, so we would just use that for a question like this on the test.
Yeah.
Okay, so we're not
Or
going
you
to
can
be
use. Yeah.
we're not going to be given it, correct?
I probably will give it to you if I want you to use it. I mean, it's from the textbook, so it should be. I'll probably just give it to you though.
Okay, thank you.
Okay. You're welcome. Yeah, the area you're not going to have to calculate by hand. That again, that takes calculus. So I'm not going to expect you to do that. Not to say you can't do it. I'm just not going to ask you to do it. Although, as we'll see later, maybe not today, but Desmos can actually calculate it for you. So, all right, let's go to this one. This one originally I was going to have everyone try. This is actually from the textbook. So but I want us to do this together. So here we have, hope I'm saying this right, the systolic blood pressure in millimeters of males. It has approximately normal distribution. The mean is 125. And it turns out the standard deviation is 14. Now, I don't know if this is actually true, but again, I got it from the textbook. So here, let's find the systolic blood pressure of a man with a z-score of 0.75. And we want to know if this is unusual or not. So here I'm giving you the z-score. And if you look at the second one, it's the same thing. I'm giving you a different z-score, but you're given the z-score. We want the data value. Okay. And then for part C, we want the percentage of males whose systolic blood pressure is less than 160 millimeters. Okay. So for the first one, here I give you the z-score, right? And again, we want the data value. So the z-score is always equal to the data value minus the mean divided by the standard deviation. So we have all this. We just don't know the data value. That's what we're looking for. Okay. So we have this equation. Let's get the 14 out of there. We want to solve for x. Okay, so we can multiply both sides by 14, as you can see. And that helps us because what that does is that kills off this decimal, right? Because we want to get x. We want x as our unknown. So we have 10.05 equals x minus 125. Now, how would you get x? You can add 125 to both sides. So we get, when we do that, we have 135.5 equals x. So in other words, x is equal to this. That's the data value. Now, with the z-score alone, you can determine if this is unusual or not. This is actually not unusual, mostly because the z-score is between -3 and 3. The z-score is between -3 and 3.